Hey y'all, this is Miss Phipps, and I'm going to be going over, hopefully quickly, a quick conversation regarding centripetal force. Now, as a quick review, we've got what you learned in some previous stuff is that centripetal acceleration is equal to the velocity squared divided by the r. The definition of this is that it is the acceleration needed to keep an object moving in a circle. Come on, it's going to be a bit obnoxious apparently. Okay. And the reason why you have to have one, even if something's moving at a constant speed, is that if it's moving in a circle, it is constantly changing direction. Therefore, you have that acceleration. So basically, even at a constant speed, there has to be an acceleration that keeps it moving in a circle, and that's the centripetal acceleration. Now, the centripetal acceleration, so that's the acceleration needed to keep it moving in a circle. Well, then we need a force that's equal, that keeps it moving in a circle, and that's force, centripetal force, is equal to mass times the centripetal acceleration, which we can rewrite as v squared over r. So this is what our centripetal force is. Now, let's talk a little bit about conceptual understanding where centripetal force fits into the entire kind of force framework. So there are two categories of forces, basically. We have the types of forces and the direction of forces. For the types of forces, we have things like the normal force, force of gravity, tension, friction, anything applied, and more, just ones that we haven't quite hit yet. But those are the ones we've hit so far. Centripetal force is not in here. It is not specifically a type of force. It is more a direction of force. So when we're taking the net force of something, such as basing it off of Newton's second law, net force is equal to mass times acceleration. Centripetal force fits in like this. Forces in the x direction, some of the forces in the y direction, and then there's some of the forces, all right, making the circle, some of the forces making it move in is equal to the mass times the centripetal acceleration. So this is where, this is what centripetal acceleration is. It's really more of a directional thing as opposed to a type of force. So what that means is that we don't really say that, oh, this is a centripetal force. Okay? Every centripetal force is a type of force. Okay? So if you've got a car that is going around a circle, okay? So the car is going like this. There's a centripetal force that pulls it in. So what is that force going to be based off of? Okay, so let's take a look. So you've got the force coming down, and generally speaking, if it's going around a circle, it's banked or something, so it's at an angle. So you got the force going down, and you'll have basically the normal force coming up, and here's the centripetal force, right? Well, actually, right, here's the thing. What's keeping it moving around in a circle? Okay, so the question is what's keeping it moving around a circle is going to be friction. Okay, so our friction force, wrong direction, which way is our friction force going to be? Well, if it's keeping it moving in a circle, this has to be our friction force. This is our weight force. Okay, so then what is our net force? Our net centripetal force? In this case, it's friction. Okay. By the way, that's also kind of how I knew friction wasn't doing this. Okay, because it can't. If friction was doing that, it wouldn't be going in a circle, would it? It has to be the force that's going in the circle. So let's talk about a little bit more specifically about a very common problem called the yo-yo problem. So let's do a circle.